Good morning everyone. Today we are going to discuss another questions from Acer Green, and this is related to organic chemistry, and let's start this one. So the simplest of the lipid are the fatty acids found in the fatty tissue of animals and in the membrane of their cells. All fatty acids are long chain alpha carboxylic acid, that is they have the organic acid carboxylic attached to one end of the hydrocarbon that has between 10 and 30 carbon atoms. Figure 1 shows a typical fatty acid, palmitic acid. Okay, so this is the structure of a palmitic acid, and you can see this is the carboxylic one, and here we have some fatty acids. Let's start with the question. So as you can see here we have 32, which is talking about a group of 3 fatty acids that are all saturated. It is talking about which of the following are saturated. So look at here. If you look at this carbon chain, how many carbon here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. How many hydrogens? 3 to 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29 and 31. So this is the palmitic acid, and the carbon and hydrogen here 6, 15 and H31, which is saturated. Single bond means saturated. This is saturated. Clear? So how can we say any hydrocarbon can be saturated? So look at here the hydrogen's number. The hydrogen number means number of hydrogen here 2 into number of carbon plus 1, you can see. For this you can see 2 into means here carbon is 15. Okay, so 15 to the 30 and 30 plus 1 is 31. So whenever your number of hydrogen is 2 into carbon plus 1, that will be saturated. So look at the capric acid, C9H19. So you can see 9 to the 18, 18 plus 19. So C9H19, which means saturated. 1123, again it is 2 plus 1 means 22 plus 1, 23. This is saturated. Mystic C13H27, again saturated. 1529, this is unsaturated. 1531, this is saturated. 1729, unsaturated. Linolenic 17H31, unsaturated. 17H33, again unsaturated. Steric 1735, which is 2 into carbon plus 1, which means saturated. 1931, unsaturated. 1937, again unsaturated. 1551, 2551, which means saturated. So saturated is quite simple, means number of hydrogen will be double into carbon plus 1. Clear? So let's discuss the question. Capric, steric and cerotic, gaddic, oleic and arachidic, saturated. So capric, steric, let's check option 1, capric, steric and cerotic. Capric, steric and cerotic. Yes, you can see capric saturated, steric saturated, cerotic saturated. So option A is absolutely right. Clear? Capric, steric and cerotic. The number of double bond in arachidinic acid. Arachidinic acid, we have to figure out number of double bond. So first of all, look at here. Suppose you have any hydrocarbon which is the saturated one. Suppose this one. This is saturated, okay, single bond. So how many carbon and hydrogen here? C2H6. Suppose we are going to convert this 2 carbon chain into unsaturated form, which means double bond. and we can balance like this, because we all knew carbon valency is 4. So you can see here this carbon is 2 in the left, 1 in the right and 1 in the downside, so overall 4. So here the molecular formula is C2H4. So you can see here this saturated to unsaturated. Here hydrogen is 6, here hydrogen is 4. So there is a loss of 2 hydrogen, loss of 2 hydrogen. Clear? By presence of one double bond. One double bond means if we have one double bond, it means there will be a loss of 2 hydrogen. Clear? So same approach in arachidonic. Look at here. This is arachidonic. The molecular formula is C19H31. C19H31. And this is unsaturated. So suppose if this is going to be saturated, then what should be the molecular formula? So if it is going to saturated, we all knew the number of hydrogen. Here we can say the number of hydrogen will be what? 2 into number of carbon plus 1. So here carbon is 19. So 2 into 19 plus 1, which means 39. Clear? How many hydrogens lost here? 31 and 39. Clear? It means 8 hydrogen. So one double bond, loss of 2 hydrogen. So 8 hydrogen means 4 double bond. Clear? So it should be 4 double bond here. Arachidonic acid, the number of double bond will be 4. Clear? Now 34. Cottonseed oil contains large amount of polyunsaturated fatty acid. When the oil is used to make margarine, the fatty acid are changed chemically in order to increase their melting point. One change that would achieve this would be. So look at the stem here. As the fatty acid indicated in figure 1 has an alkyl chain that is saturated. So this is saturated. Contains no side chain or branches, its molecule can pack closely together. What does it mean? It means saturateds are closed packed structure. Closed packed structure, solid at room temperature. Many fatty acids are unsaturated, having more than one double bond. Such bond alter the shape of the molecule and prevent them from packing closely as the saturated molecule. So simple thing is that unsaturated hydrocarbons have, or fatty acid have, you can see alter shape. So what does it mean? Look at here. When we have closed packed structure in a crystalline solid, that means high melting point. And once we have, you can see here, alter the shape of the molecule, prevent them from packing as closely together, means they have not well packed structure. So unsaturated has low melting point. So simple thing is that saturated has closed packed structure in a crystalline solid. That's why they have high melting point, while unsaturated have low melting point. And the difference between saturated and unsaturated is the presence of double bond, not the chain or anything. You can see there is no double bond here, but the unsaturated have a double bond. So the very first option is decreasing the pH of the mixture of the fatty acid. In stem there is no use of pH or anything. Second, adding alkyl side chain of the hydrocarbon chain. Again, there is no mean of it. Side chain doesn't influence the saturated or unsaturated part. C, reducing the number of double bond. Yes, it is absolutely right, because if you have a double bond and if you are going to reduce into single bond, this is called saturated, well packed structure and high melting point. High melting point. Clear? So the answer will be C. Now the 35, the iodine value is a measure of the number of double bond in a fatty acid. One molecule of iodine react with one double bond. So one iodine react with one double bond. One double bond. The iodine value, that is called iodine value. So the iodine value of capric, gaddic and arachidinic acid are in the order. Again listen me. Capric, gaddic and arachidinic. Arachidinic we got 4. So arachidinic has 4, there is no doubt. 4 double bond, it means 4 iodine value. 4 iodine value. Because iodine value is equal to number of double bond, okay. So now we have to figure out for capric and gaddic acid. This is the capric and where is the gaddic? This is gaddic. Look at here, capric is saturated. So there is no double bond. Clear? So it should be 0. And for gaddic acid, this is C15H29. Suppose this is saturated, then how many hydrogen here? This is 15 carbon. So 15 to ja 30, 30 plus 1 is 31. So how many hydrogens here? This is 29 and this is 31. So there is a 2 hydrogen gap. 2 hydrogen gap means 1 double bond. 1 double bond means 1 iodine value. 1 iodine value. Clear? So here we can say arachidinic has the highest. Oh, A, B, C, they have arachidinic here middle and here in the last. So A is wrong, B and C is wrong. Only option D in which arachidinic has the highest one. And we all knew capric is 0, so in the last. So D is the right choice. Clear? So this is organic chemistry Acer Green. Thank you so much for watching this. Please share and subscribe.